Good afternoon, everyone. Good afternoon. Good afternoon. So I see a lot of things happening now within IIFT. Means everyone is all of a sudden busy and okay. So you guys have got a date when you have to come to campus? Next week, okay. Okay. So let me share my screen. Mm, can someone give me presentation rights? Is there anyone who can give presentation rights? No? Yeah. Satya, can you give me presentation rights? Okay, thank you. Okay. Cool. So, where we stopped, I mean, what we covered in our last class, can anybody would like to just recall?
I think, sir, we covered the unbalanced transportation problem and then solving those through Excel. And we were about to start, I think, duality for these transportation problem.
Correct. So, what we have done in our last class is that, taking from the previous class, we kind of tried to solve transportation problems using Excel. And a class before that, we did worked on the balanced transportation problem, where supply was equal to net supply was equal to net demand. And then in the subsequent classes, at the last class, we have solved a couple of more, and also we kind of tried to cover that uh, not all the problem statement may look like transportation problem, that you will have clear definition of supply or clear definition of demand. But when you start formulating the problem for its unique characteristics, that you have a set of nodes and you have a set of node sources, you have a set of destination nodes, you have to send from source to destination in order to achieve certain objective, and there are certain costs which are associated. In fact, there is a transportation cost which is associated. And if you are able to identify these nodes, most likely the problem we will be able to formulate like a transportation problem. Transportation problem is similar to LPP, with exception that it has typically the constraints are equal to constraints, where we need to meet certain demand requirements at certain locations, keeping in mind that there is a supply or the capacity constraint. Once we started with balanced problem, then we have seen some of the non-conventional transportation problem, means transportation problem whose statement is not necessarily like a transportation problem. And then we worked on an unbalanced problem, and we said that if this unbalanced problem, depending on whether it is overstock or understock, we will include the dummy source or dummy destination, and we will associate a cost 0, so that any excess demand or excess supply can be allocated to this. And then after that, the allocation principles will follow, same as what procedures we have done. In terms of solving it, we have used 3 methods. One is the northwest corner method, least cost cell method, and Vogel's approximation method, or we also sometimes call as VAM. We have seen that these 3 different methods may give rise to different feasible solution, and in particular instances it may be optimal solution, may not be optimal solution. We have also seen that why northwest is used, or rather we have talked why northwest is used, because of its simplicity and capability to derive a basic feasible solution the quickest possible way. Okay, so that's what we have covered last class. Any queries or any other questions before we start today's class? Okay, I think you will have one quiz next week. Already got some intimation, and very likely you will get your next assignment also in this coming week. See, we'll have to schedule another quiz in the subsequent 1 or 2 weeks time frame. Okay, so let's first cover it. We will, towards the end, we can say if we have. Okay. We will quickly cover optimality test, and then we will go for assignment problems, assignment of work to different workers. Listen very carefully. I mean, the optimality test for transportation solutions is a little bit computation intensive, as well as a lot of steps are involved. But often with a little effort you can find out a better solution. We will first go through the theory portion of it, so bear with me, stay with me the theory portion, because once that is done we will see an example also. The reason of putting theory first is that when we go to the examples we are able to recall the theoretical statements. Okay. So we have known that using some of those 3 methods, we are able to find out a basic feasible solution, which is pretty much acceptable in a different instances, but that may not be the optimal solution. There is a possibility that there is a solution which is better than that. How to test that optimality? How to ensure, or rather how to find out if there exists another optimal solution within a transportation problem, given that we have some basic feasible solution. So just recall, in our basic feasible solution, we have m plus n minus 1 cells which are allocated. So if I have m number of origins and n number of destinations, I have m plus n minus 1 cells which are populated, for the rest of cells which are 0. So that's the kind of most of the arrangements we have seen so far. There are exceptions. We will not cover that those exceptions as of now. Let us see what happens when those many shells are covered. Okay, so typically there are I think 2 methods, 2 to 3 methods which are popular. We'll use one of the methods. The other methods we do not have time enough to we will not have enough time to cover all the other methods. We will use UB method, or also sometimes called modified distribution method or MODI methods. Okay. Now, just to recall in this process that we were saying that transportation problem is basically LP. So essentially means it can be designed as a primal, the way it is given to us, as well as it can be designed as a dual, where we define the dual variables for each of the constraints. For a transportation problem, the constraints are demand constraint and the supply constraint. So for each of those constraints, we will define a dual variable and we will try to solve it. However, we will not use simplex per se as such, because of this specific characteristics of transportation problem where many of the cells are zero. We will try to use something similar lines, but it's a bit difficult, different approach. So what are the first step? First step is to find out basic feasible solution using any one of the earlier methods which we know how to do. Then step 2 is introduce dual variables for the row constraints and column constraints. If there are m supply and n demand points, then there will be m plus n dual variables. Dual variables corresponding to row we will typically denote by U, and to column we will denote by Vj. However, remember here we will designate duals in such a way that Ui plus Vj equal to Cij, means the sum of the dual variables is equal to coefficients of the ijth cell. This is only for the cells which are allocated. Okay, so that means this equation ui plus vi equal to cij, ui plus vi equal to cij, which is greater than ui plus vj equal to cij for xij greater than 0. Greater than 0 are basically those cell elements which are allocated. So essentially, if I have m plus n minus 1 cells which are allocated, so I have those many possible equations of ui and vj. I'll repeat, if I have m plus n minus 1 cells which are allocated, I have those many equations for ui and vj. How many ui's I have? M. How many vj's I have? N. Because I already said in the step 2 that I have m supply and n demand points, means m origins and n sources. So I basically have n plus n unknowns, which are ui vj. For m plus n unknowns, I have m plus n minus 1 equations. In order to solve this equation, I will assign a value, arbitrary value, to one of those ui and vj's. Now that process is pretty much random. You can allocate anything in this world to any of those uis or vj's. So what I am basically trying to do here is that I am forcing one of those dual variables to certain value, known value, and we will use 0. So we will assign value 0 to one of those ui and vj's, and the example we will do is that we will assign 0 to u1. You are free to assign 0 to something else, but it doesn't matter. Okay. Now step 3 is any basic feasible solution as m plus n minus 1 cells with xij greater than 0. We already know this, and remaining cells are 0. Thus there will be m plus n minus 1 equations to solve m plus n dual variables. We just now discussed this. Since the primal equations are equalities, it is not greater than equal to or less than equal to the kind of things. It is just exactly equal. So ui and vj's are unrestricted in sign. You don't need this for solving, but just remember these theoretical aspects that ui vj are unrestricted in time, in sign. So it can, in the process of calculation, ui vj's can be any values, positive or negative. Step 4. The next is that calculate Cij minus ui minus vj. It's basically coming from this equation, from this step 2. Okay, so I'll calculate. So it's basically now the equation I have m plus n minus 1, those many equations, where I represent or write it like Cij minus Ey minus Vj equal to 0 and solve it. Okay. Calculate Cij minus Ey minus Vj for all unoccupied cells. So I'll calculate this for all unoccupied cells, that is where Xij equal to 0. Again, I'll say that don't get confused, just remember, or at least try to remember some of the steps. We will see how we will going to do. Now, if all Cij minus Ui minus Vj is greater than equal to 0, then the solution so obtained is optimal by theory of complementary stack slackness. Now, what is theory of complementary slackness? You already know that if there is an optimal solution in the primal, there is going to be an optimal solution in the dual, and both will be same when optimality is achieved. So that's the kind of foundation of complementary slackness property. If one or more of those Cij minus Ui minus Vj is less than 0, then we will okay, I mean, let's, for the time being, it's a little bit tricky to understand, try to understand anecdotally. So remember the steps. If one or more of those things, Cij minus Ui minus Vj less than 0, we select the cell with least value and allocate as much as possible, subject to demand and supply constraint. So what practically I am doing, I am basically, in the process, I am trying to search for a particular condition where Cij minus Ey minus Vj less than 0, and then we select the cell with least value on that particular item and allocate as much as possible, subject to demand and supply constraint. So we will identify a cell where this condition is violated, and on that cell we will allocate, but we will remember the demand supply constant should not be broken, such that my constraints are still hold good. Now, in practice, what we are doing, basically we are changing the allocation from current feasible solution to another cell of lower cost items, and then checking if I am getting a better solution. But since I have only limited number of cells which are occupied, therefore there are huge number of possibilities that is that I can test. So practically, if it is a 3 into 3 cross matrix, that is possibly do it humanly, but if it is 50 into 50 matrix, that is not possible humanly. So that is the algorithm. This is the algorithm that we will use. The allocations on of the number of adjacent cells are adjusted so that one of the basic variable becomes non-basic. What essentially means is that we will ensure that the allocation or total number of allocated cells remain m plus n minus 1. So when you are adjusting, we'll ensure that one of those cells turn out to be zero allocation in lieu of some of the other cells where I am now allocating, and then adjust all the other allocations to ensure that demand and supply constraints are met. Once that is done, we will check whether I have achieved optimality. If not, if I am not improving my result, I will stop this solution. I'll again do that. If that process is done, I will redo the exact same thing what I have been doing from step 1 to 4. Okay, let's see. So for example, this is the transportation cost problem. Okay, is it balanced or unbalanced?
Balance.
Sir.
So let's try for a basic feasible solution. Can anyone quickly try for a basic feasible solution? Any of the methods? Anything is fine. I mean, you can do any, choose any of them. I think I have used. Just spend 5 minutes because we will have to anyway do it uh, in both exam. Let me know if one of you have got any question.
$465.
Okay. Which method you used?
Least cost method.
Let's see if anyone.
590.
590. Which method you have used?
Least cost method.
So both have used least cost and you have got different result, is it? That's something strange. Who has got 465? Can you let me know the allocation? I think 465 we will not get it in least cost.
Sir, I spotted a mistake.
Okay, no problem, no problem. Okay, anyone else has got any other cost?
Sir, I have solved using northwest corner method. I have got 625.
625 northwest. Okay, I think 590 list cost is the correct one. Let me see. I also used list cost. I tried the other also. Nobody has tried Vogel, VAM. No? Okay. Fine, let's proceed. I think you can continue. So, yeah, I used some methods. I got also 590. You can choose any methods. So that's not a big thing. For classroom example, we'll use this allocation. We'll start with it. So the first step one is assign U1, U2, U3 for row constraints. Keep your matrix with you. Okay. As we talk, we would be referring that very frequently. So now assign U1, U2, U3 for row constraints and V1, V2, V3 column constraints such that remember only for the occupied cells. Okay. So you allocate U1, U2, U3 for this constraint, V1, V2, V3 for this constraint such that Ui plus Vj equal to Cij only for Xij greater than 0. That means U1 plus V1 is equal to 8. U1, if this is the allocation you have got, if you have got some other allocation, you will have to follow that. U1 plus V3 equal to 7. So bracket is the allocation because I don't have luxury to put like exactly in a word. What otherwise typically word may you will see there is a small square bracket and then their cost is written so that that cost is just a reference big item you will be kind of allocation, which is fine. Okay, anyway, U1 plus V3 equal to 7, U2 plus v2 equal to 3, like that. Okay, so that is precisely what I am doing here. u1 plus v1 equal to 8, u1 plus v3 equal to 7, 3, 5 and 6. Now look, you have u1, u2, u3, v1, v2, v3, 6 unknowns. You have 5 equations. So we will force one of the variables or unknowns have to get some value. Here we will assume u1 equal to 0. So can you write down the equations for all these things, and then you say put value of u1 equal to 0 and solve rest of the other equations. Listen again, when you put u1 equal to 0, now you have exactly 6 variables and 6 equations to solve. So you should be able to find out the value of u1, u2, u3, v1, v2, v3. Can you do it on paper and let me know?
Uh, Sir, I think your voice is breaking.
Is it better now?
No, sir.
No? Okay. Hello? Hello?
Yes, sir. Now it's audible.
Okay, and let me try to hold it for this because there are some electrical work going on. I'm not sure because of that if network strength is impacting. But anyway, let me know whenever there is a problem. We'll see. So what I was saying is that now you have all the equations and value of u1 you have we have said that equal to 0. Can you solve for u2 u3 v1 v2 v3, and you can solve it. It's a simple solution. Let me know what are the values.
Sir, will some values be negative also?
Yeah, we said that it is unrestricted in sign.
Uh, V1 equals to 8,
Okay.
V2 equals to 6,
Okay.
U2 equals to minus 3,
Okay.
U3 equals to minus 1, and V3 equals to 7.
v3 equals to 7. Okay, let's see. -3, 0, -3, -1, 8, 6, 7. Okay. So has everybody got it right? I mean, there's nothing to get it unless you do some incorrectly. Okay, so now what you do, you calculate penalty for the unoccupied cells by using the formula Pij equal to Cij minus Ui minus Vj. Again, I repeat, penalty is only for unoccupied cells. What you do, corresponding to that cell, find out the coefficient values and subtract the Ui and the Vj's. Okay, so what are the unoccupied cells here? Sorry, what are the unoccupied cells here? This cell, this cell, this cell, this cell. So there are like 4 cells. So unoccupied the penalties on all those 4 cells. Sorry, calculate the penalties for unoccupied cells and let me know what are the values. Anyone who is confused how to calculate this penalty?
So penalty 1, 2 equals to 3.
Penalty 1, 2. Okay, fine.
Penalty 2, 1 equals to -1.
1, 2 equal to 3. Okay. 2, 1 equal to 1. Okay. Yeah.
Penalty 2, 3 equals to 1. And penalty 3, 1 equals to 1.
1 equals to 1. I see.
Oh.
Okay, I'll have to check it. Penalty 3. Three, 1, 8. Okay, right. Yeah, this is 1. Okay, so that's fine. I think I'll have to recheck it. There is a negative value. Now, what is important is that all the penalties are positive except one, penalty 2, 1, right? There is a negative value which indicates a potential gain by readjusting allocations while still meeting the constants. Now, what we will do, 2, 1, there is a negative penalty. When there is a negative penalty, it means there is a possibility. I'm not saying that is for sure. There is a possibility that we can just readjust allocations against this cell, or using this cell, we may get a better solution. So how do we do that? This is 2, 1, right? Let's come to 2, 1 cell. So this is 2, 1. So this is the cell where there is a negative penalty. So there is a possible that we can readjust allocations. So how will we adjust the allocations? Here I can either give 25 or 30. So how to do it is basically a loop formation, how it is done. We will see if how much we can cover. So basically we'll start with 4 and see if 90-degree turns can just go to only allocated cells. If there is a break, then that means the loop is not formed. Again, I'll repeat this part. So it's basically if we start with this negative penalty wala cell, we start forming loop by moving 90-degree in, say for example, clockwise. We go 90-degree this way, which is annotated. From here we'll go to 90-degree. There is a skip cell which is okay. From here I go to 90-degree. I get here. So I form a loop like this. So there is a possibility of allocation. If there is a break, that is possible. I mean, it's a 3 by 3 matrix. Possibly there will not be any break. But if it is a huge matrix, there possibly will be a break, because you cannot go from here to 90-degree any direction to get a potential possible allocation. So what we will do is that we will change from cell 3. Okay, bring it here 25. Okay, so just this is the problem. It was 25, now it is 0. We will allocate this 25 here. When you allocate 25 here, it breaks my constant of 30. So we'll make this allocation 5. The moment I make this allocation 5, here are 35 more supply which is possible. I allocate 35 here. 5 plus 30, 40. So this condition is not broken. However, this condition is now broken because now I have 35 here and 30 here. So I'll have to make this 5. And when I make this 5, I have to adjust here in order to make this constant. So what I'm doing here is that I'm moving from this cell to this cell to this cell to this cell to this cell, and like that. So now in cell 3 I don't have any allocation. Earlier I have 25 allocation, and I have in cell 2 I have all the allocations when number of total allocated cells remains same. I then calculate the cost of newly allocated cells, which is coming at 445. Okay, so essentially the crux of this method is that we calculate the duals so that UI dual for each of those constraints where I have already allocated are equal to the corresponding cost. Now I know for m plus n dual variables, I have m plus n minus equations, minus 1 equations. So I kind of put one of the dual variables value equal to 0, and then calculate penalty of all the unallocated cells. Remember, your dual values are unrestricted, so they can come minus, plus, or whatever. Then I calculate penalties using the formula Pij equal to Cij minus Cy minus Vj. And if some penalty is coming out negative, means there is a possibility of readjusting the allocation to reduce cost. How will I find how to readjust? We create a loop within this matrix. We will just take 90-degree turn and see that it is either going to allocated cells or coming back to my pivot cell. Okay, so for example, if this allocation was here, then I will go from here to right, and then I'll go from here and here and this way. But however, if this allocation was not here, I have only allocation on O1 H2, then I will start from here, here. I cannot go in this cell. I'll have to come to this cell and like that. However, once I am in this cell, I do not have path to go back to my pivot cell because this cell is unallocated. So that is what called a loop formation. That's the basically brute force method. Why the loop formation is looped is that when you adjust in one cell, it is going to violate either of demand or supply on that row or column. If you do not have any cells allocated on that row or column, you will possibly not be able to meet the demand or supply constraint. Only when you have another uh, allocated cell, you can change the allocation on that cell. Remember, in this process, we will change only one cell at a time. Means one of the earlier allocated cells will become 0, and one of the non-allocated cells for which penalty is negative will have allocation, provided that my cost is reducing, provided that I am able to meet supply and demand constraint. Once that is done, I can recalculate the UV and see if there are still further improvements is possible. How? If there is some penalties which are still negative. Now, if some penalties, if say for example in this process you have two of the penalties which are coming negative, so I will choose the one which is highest in terms of penalty. So, and then see whether I am able to do that. But for classroom and examination purpose, you possibly will not have that situation. This is because it's a little bit computational intensive. Okay. Okay.
So in case there are two allocations in the same row, which one will take the value higher one or the lower one?
Two allocations in the same row, like here, if you have this row allocated and this row is allocated, that's what you are saying.
Say suppose 20 is allocated with 3 and 5 allocated with 5.
So for changing, you will choose the minimum of those two. So otherwise, adjusting to the demand constraint and supply constraint will be difficult. So the actually thumb rule is that you change the list of values adjacent to this penalty cells, adjacently allocated to this penalty cells. So for example, if it was 5 and it was 25, you would have done it 5. If it is 25 and here it is 5, we will interchange between these two. Okay. But if this is 25, this is 5, this will has to be 25 and 5 because 25 is the adjacent to the 4, not the far sighted one. Okay.
Okay, sir.
So there is a gain of UI and VJ, and then we again do the same UI VJ calculation, and then we will see the penalties are now all positive. Okay. I think there I did some calculations here. P31 is 1. Okay. Thanks for pointing out. Okay. So essentially at any time you will have m minus n into n minus n number of Pij's. Can you tell me why? Okay, my question is that when you are doing UV calculation at any given point of time, you will have m minus 1 into n minus 1 number of Pij's. That's what um, given that it's a standard problem. Can anybody tell me why? Or at least try to guess. It's a math question. It has nothing to do with UI VJ operations research.
The total number of cells will be m into n, and the number of allocated cells is n plus n minus 1. If you subtract that, we get n, whatever is written, n minus 1 into n minus 1.
Yeah, absolutely. Okay, for those who are not able to follow, you have m cross n matrix of which m plus n minus 1 cells which are occupied. So that means unoccupied number of cells are mn minus within bracket m plus n minus 1, which if you just do a simple adjustment, you will see that basically unoccupied cells are m minus 1 into n minus 1. Anyway, since all penalties are positive for this particular problem, in this iteration we consider the solution as optimal solution. Okay, so that's a simplistic view of achieving optimality. We can do this complex UV method, but I think that is a little bit time consuming given that our session is almost over. You can, I mean, if I just tell you that it will come to exam, possibly not correct, but I will try to see if not a very complex UV kind of approximation is given in the exam, but you should understand the foundation, how once I have a transportation basic feasible solution, how I should approach to achieve my optimality. Okay. Okay. So we are done with the transportation problem. We will start with the assignment problems. So anyone who is comfortable with these things, what was the unique feature or similarities between transportation and LPP? Because transportation is a subset within LPP, I said, but what was unique in transportation problem? We have source, we have destination, we allocated from source to destination in order to meet the demand and supply. However, remember, when we have allocated source to destination, it is highly possible that one destination is allocating to multiple sources. Okay, you get it? Just this, look at this problem. So this origin is allocating to both supply center S1 and supply center S2. So origin is the source. So when I say origin, you remember this is the source. When S1 is basically supply point, is the destination where you will have supply requirement. Now, in a typical transportation problem, we have seen that one source can deliver to multiple destinations. So also one destination can be sourced from multiple origins. Okay. Now, when I'm saying assignment problem, this is a special form of transportation problem. If you can recall earlier one in the last class, I was saying that this is basically a single objective network optimization problem. All these problems come as single objective network optimization problem as well as single product. So even assignment problems belongs to kind of that similar genre. What is special in the assignment problem that makes it unique as compared to transportation problem we'll cover shortly. However, remember it is a special kind of transportation problem where we will have source, we will have destination. However, typically this is about, if you can just anecdotally understand, when you have a set of tasks, you are assigning tasks to a set of resources such that every resource will be doing only exactly one task. Also, a task will be performed by only one resource. I repeat, you have certain number of tasks to achieve. You are assigning those tasks to a set of resources such that every resource is or are working on exactly one task, and every task is completed by exactly one resource. So there is a one-on-one correspondence. So then that means number of tasks and number of resources is likely to be equal. Otherwise, if the resources are less, some of the tasks will be unachieved. Okay. Given that this is my objective to allocate tasks to a given set of resources, what should be my objective function? I don't need I don't need equation form at this moment. What could be my objective in this process of assignment? Anyone? Okay. Let me help you. I give you some projects to for presentation as a OR project presentation. You have 6 people in your group. Okay. And you break the work of this project in 6 non-dependable chunks. For example, one person just looks into the data, one person just looks into the background information, one person just looks into whatever, all these things. So you break it down into, for example, 6 buckets. Now you are going to allocate those 6 subtasks of bigger task, which is the project assignment. What should be your objective?
To do it in the least number of time.
Correct. So objective is to minimize the overall accomplishment. Okay. So reduce the overall time of accomplishment. So that is the objective. So now I was talking in terms of task and allocation to your own fellow. In some other aspect, it may be cost. In some other aspect, it may be time. If you recall that it is time, and remember that way, it helps that you basically try to minimize total times of accomplishment. Okay. So assignment problem deals with allocating various resources to various activities. Here resources are items and activities are basically resources. That's okay. Don't confuse with the terminology. It's basically you have tasks and you have resources who perform the task. Remember this way. Allocation is one-to-one basis. Remember each operator perform exactly one operation. Now my objective is to minimize cost or minimize time of completion. In its classical form, means from where it has come, it's about allocating jobs to workers where skills difference dictates the job completion or cost of accomplishments. So that's precisely the same example in case of your project report completion point of view. Suppose one of you are very good in data crunching, the other person is very good in making presentation. Forget about for MBA students, making presentation is like a hygiene factor, but that's okay. Maybe one person does a fantastic presentation skill, another person is too good in terms of secondary research, something like that. So every person, for example, you allocate the task of data crunching to the person who basically prefers secondary research. Obviously, he will take more time. So that means depending on your skill sets, your accomplishment of task varies. So therefore, your total task completion time varies. So that is precisely is the core objective of typical allocation or assignment problem. And obviously, if number of workers, number of jobs does not match, you can always add fictitious workers or jobs just to achieve the optimality. Obviously, like in case of unbalanced transportation problem, some of the demands was still unmet, or some of the supplies was not able to meet some of the demands was unmet, some of the productions was still kept in the factory. Here also some of the tasks will be unexecuted, but in order to solve your problem, you can always include dummy resources or dummy tasks if the situation is like that. Okay, now what is the difference and similarities between assignment problem and transportation problem? Obviously, assignment problem is a special kind of transportation problem. Now, what is the specialty? Is that there one origin can send it to two supply locations, or one supply location can fulfill its demand from two origins. Here it has to be 101, which essentially means the matrix, the m into n, that matrix we have been dealing with will be even more sparse, means there will be even more zeros. Okay. Number of sources are exactly same as the number of destinations. Capacity of each source is 1. Capacity means the capacity of doing task. So each source can do only exactly one task. Demand of each destination is 1, means every task has to be performed only by one time or by one resources. And then the matrix is going to be square matrix because I have same number of tasks and same number of resources. However, in transportation problem, we have seen the matrix is not necessarily a square matrix all the point of time. Okay, so this is typically how the matrix may look like. You have job per machine, you have jobs from 1 to up to n, then you have machine 1 to up to n. I will identify job marker as I and machine marker as J so that I can identify cells as Cij. But essentially here I equal to 1 to n, J is also from 1 to n. Okay, so both I and J are basically maximum values same. Okay, this is the same kind of representation. It's just that I was thinking that putting it in PPT might take longer time. So you have workers, you have jobs, there are n workers and n jobs, and then like that you get the matrix and each constant belongs to one. Now, in order for formulation's sake, Cij is same exactly represents the amount of time taken by the ith worker to perform the jth job. Again, the Cij in the context of LP is basically my coefficients. Let Xij denote the jth job allocated to ith worker or the person. Hence, the objective function will look like what? Can anybody tell me? Okay, before that, what are the values of Xij? Okay, what is Xij? Xij denote that jth job allocated to ith worker. Slash person is basically it will be or person. So basically jth job allocated to ith person. What could be the values of Xij? Any guess?
1.
Right, so Xij is either 1 or 0. Now tell me what is the objective function?
sigma of Cij into Xij, minimizing sigma of.
Correct, absolutely, very good. So my objective should be sigma of Cij Xij to minimize that. Okay, so the objective function is to minimize Cij Xij for I equal to 1 to n and j equal to 1 to n, such that value of Xij equal to 1 if the ith person is assigned the jth job, okay, and 0 if ith person is not assigned the jth job. And also xi1 plus xi2 plus xin equal to 1 means in that row a person will be allocated exactly one task. Similarly, in that column a task will be performed by exactly one resource. Okay. Now Cij is the completion time or cost or some other parameter that has to be minimized. Just bear with my spellings. So that has to be minimized. Okay, so this is basically the formulation of a simple assignment problem. Let us see when we can go with. This formulation has a different form, means structure. All essentially tell the same story. This is the LP formulation. Whatever I have said above is just written in a different way. Minimize this and all these things. Xij is greater than or equal to 0. So it's basically either 1 or 0. If you see this is the LP formulation, then this is a binary formulation of the same thing. It's all about telling the same thing in a different mathematical language. And also like if you are using some tools, it might need separate kind of input. Okay. Anyway, doesn't matter which formula is using. So let us try to solve assignment problem. So we'll be using one of the quite popular assignment problem solution, and honestly I'm not sure if any other things which are popular like this, and this is possibly the only one I have come across. So what we'll be doing is called Hungarian method for solving assignment problem. Now, just to tell you that Hungarian method is essentially used for calculating by hand. And it was introduced for that purpose also, because one point of time project scheduling, completion time and all those things, they were using this method. But now because of software, we may not need to do it, because if you are good in Excel, and if you are able to formulate it in Excel, then the moment I put my Excel's this input, we're not going to do this assignment in Excel because we will not have that much of time in hand. But if you put it in Excel, you know already transportation problem how to put it. You just here you'll have to restrict Xij as 0, 1. That's it. If you just give it in an Excel, it will give you a solution. That's the point. Otherwise, Hungarian method is something which has to be done in hand, and it is good to know the philosophy, the operating procedures of solving assignment problem. Okay. So first of all, you check if the given matrix is square. If not, make it square by adding suitable number of dummies or columns. Okay. Allocate zero cost or time, whatever, for those dummy entities. These things you know already. I've been talking to this for a long time. Now locate the smallest cost element in each row of the cost matrix. Cost matrix means what are the row designates my resources which will perform those activities. To find out in each row what is the smallest cost means what we are trying to find out that person is good at accomplishing which task. Okay. So locate the smallest cost element in each row of the cost matrix and subtract the smallest cost from every other element of the row. I'll repeat. Find out a row, find out the least cost in that row, subtract that least cost from every other element. So what will happen? You will have one of the rows, at least one of those entities will be 0. You may have multiple depending on problem to problem, but you will have at least 1 0 in that row. Okay. It means for each worker, find out which job takes less time and find out how different is it from other jobs. When I'm subtract it, it basically tells me that instead of doing this job, if I'm doing some other job, how much extra time this particular resource is going to take. In the resulting new matrix, locate the smallest cost element of each column. So एक बार once you are done with these steps, you will get a new matrix with the new cost elements. Now on that new matrix, now you go to the column item. In those column items, you find out which is the smallest cost element of each column and subtract that cost element from the other elements of the column. So whatever we have done with row, now we will do it column, but just that my matrix is now a new matrix. Okay. In the resulting matrix, search for an optimum solution as follows. So now what you have done, you have identified a resource for whatever task it gets accomplished the least possible way, and then subtracted that from the rest of the elements of the row. That means now you know if this resource is not allocated, this task, something else is allocated, how much time it will take. Once you have done it for entire row, now you are coming to a column key. If this task has to be performed, then which among these I will choose where I have the least penalty, and then subtract that from the rest of the other elements. So now possibly almost all the columns will have some zeros also. Okay. Now examine the row successively in the resulting matrix. Like that, once you are done with rows and columns, in the resulting matrix, search for an optimum solution. How will you search? Examine the rows successively. So we'll start with first row. You will find out that if there is a row which has exactly 1 0, draw a rectangle around this 0 and cross out zeros in the columns. Okay. So if you find out a 0 in any row which is a 1 0, if you find out 2 zeros, means that guy possibly can do both of these tasks equally. So we will avoid that cell, avoid that row. We will only check the rows which has exactly 1 zeros. If it has got exactly 1 0, we will mark it as a rectangle and we will mark out all the other zeros. Means ये काम ये वाला बंदा ही करेगा. Okay, so this work will be done this though, so other zeros mark it as a 0. Continue this search for the next rows and go on till you are in a 1 zeros kind of situation. So row में एक zero है, fine, mark it. Column में जो जहाँ पे zero है, you kind of cancel it. If you find any row with more than 1 0, skip the row and move ahead. Once you're done with this row, this step, then you start with the column. If there is in some column you have exactly 1 0, mark it. Remove all the other zeros of the row. Why? Because now you have booked for that task to that row item, and then ensuring nobody can allocate anything to that person. Again, for column also, you will do exactly that. Whatever column has exactly 1 0. If a row or column in the resulting matrix contains more than 1 0, if a row or column in the resulting matrix contains more than 1 0, then choose row or column having minimum zeros. In this column, okay, we'll see this to an example. I'm sorry if things are getting confused. So I think I'll have to keep switching between slides. Okay. Okay, let's see. Let's here. We will do an example. Quickly take a snapshot and write it down on paper. Okay. You write it down, that will help us to give me a second. Okay, so now let's go back to the steps.
So can you go to the question 1 second? I will just take a snippet.
Okay.
Thank you, sir.
So all of you have either taken a snapshot as written down, right? Matrix. Okay. Start from. Typically, okay. So it is a given matrix. Is it a square matrix? Yes. Is it square matrix?
Yes.
Okay. That is precisely what I was afraid that I have to keep switching, but that's okay. Locate the smallest cost element in each row of the cost matrix and subtract the smallest cost from every other element of the row. You can do that, right? Do that. If anyone is facing any problem, let me know. Any confusion? Once you're done, and then do that for once you're done, then do that for the column also. Done.
Yes, sir.
Okay. So okay. Now first step. Examine the rows successively until a row with exactly 1 0 is found. Draw a rectangle around this 0 and cross out all zeros in this column. Do this. So in case there are two such items in a row as 0, skip that row for the time being. We will come back to that again at a later point of time. And once you're done with the rows, do those things for columns also. Remember, every iteration will give you a new matrix. So if you are trying to do it in the same 4x4 place, you might do mistake. It's a little bit cumbersome, but better to start at least in every iteration. Okay, I'll proceed. You can continue. So once you're done with that, if a row or column in the resulting matrix contains more than one zero, choose a row or column having minimum 0. Because you are done with one 0 in each rows and 1 0 is in each column scenario. Now I'll start with 2 zeros in the column like that. But if there are 2 zeros, how will you choose? How will you break the tie? You can choose arbitrarily 1 0 and draw rectangles around this and cross all other zeros from this. So repeat this process until all zeros are either selected or crossed. Okay. Now if each row and column has exactly 1 0 assigned, then this is the optimal solution. So when we have crossed it with a 0, I basically is a representation. Sorry, when we have marked with a rectangle, it means I have now kind of blocked these resource for this task. Okay. So if each row and column has exactly 1 0 assigned, then this is the optimal solution. If not, then we'll have to find out and go to the next step. Let us see the solution first. Everybody has got this. Now tell me. Okay. So just you can check. I try to do that. Find out list cost in each row and subtract from all other costs that leads to. You can check it if it is coming this. Let me know if it is coming something different. I'll also not something saint that I cannot do mistake. Okay. So for example, for those who are still confused, in this row 80 is the minimum. You subtract 80 from all these rows. So when you subtract 80 from all the items, this becomes 0, this becomes 20, this becomes 40, this becomes 10. Okay, like that for all the rows. Once it is done for all the rows, we'll do it for all the columns. Incidentally, you will now see these columns, there are 3 zeros and this column has 1 0, like that. Now find out the least cost element of each column and subtract from all other columns. So that is the steps. Once that is done, starting from the first row, we draw a rectangle marked red here. Red is not visible, but at least some rectangle is here. In each row having a single zero and cross all other zeros in the respective column. So what I did, uh, is that I chose this because in this row there is exactly 1 0. I chose this and I marked this 0, or rather I kind of crossed this 0. Okay. Now follow this same principle and see if you are getting the same result.
Sir, do we cross all zeros in fourth row also?
This you are doing it from for the row item or column item?
Row item. So while doing the row item, why it is crossed for the 4A?
No, when you mark a particular cell square while checking for row items, you cross the column items. Okay. Because see, well, the meaning is like that. When you selected C that to be performed by 1, C will not be performed by 4. So that is the logic. Okay. When you do it column, exactly other logic. So when you mark some activities to be performed by one of the resources, that will not be performed, or that resources will not perform any other activities. So follow that logic.
Okay, sir.
Okay, so once all rows are tested, we move to the column wise. This row has 2 zeros, we'll skip it. This row has 2 zeros, we will skip it. The last row has anyway 2 zeros, we'll skip it. Then we'll start with this column, three columns. Sorry, 3 zeros, so we'll skip it. Here we have exactly 1 0, and now we will mark it and then mark all the zeros in this row so that 4 is not capable to do any other activities, but this is already marked, so you don't have to worry. So this is marked. Okay. Now since all the rows and column are exhausted, we begin rows having next minimum number of zeros, which is 2 zeros, and arbitrarily selecting the one of them cross other zeros in the respective column, like uh, basically you can choose that column which has less number of zeros, because that's a critical column, but then you can do it arbitrarily also, like I chose here. Now, so what does that means? I have done with this row and this column earlier. In this version, I'll look with the rows with 2 zeros. So row 2 has 2 zeros. I will choose one of them. I chose this one, and then once that is done, all this is marked, and then I discarded this because I have chosen activities A for this resource. Therefore, this resource should not be capable to do this work. So this is basically the one which is left out to allocate, and this is the default allocation. If I would have chosen randomly this 0, possibly this would have been the allocation. Okay, so this is the kind of final allocation. Therefore, optimality is achieved as below. So how will I know the final values? Remember, this is all revised or kind of remodeled matrix. So do not pull the data from here. Now go back to the original matrix, which is this. Find out the cost elements for this allocated cells and then sum them up for your optimal solution, which eventually in this case is coming out to be 80, 80, 190. You can check it because I don't want to keep moving to and fro. Okay, so I kind of planned for a couple of other examples. An example where can you do this? Whatever time you have left, and let me know what is the optimal solutions.
Sir, is it job 1 by machine 2?
Just tell me, let me write for everyone to see. By machine 2, okay?
Job 2 by machine 1.
Okay.
And job 3 by machine 3.
And what is the cost?
30.
Let's see what others are saying.
Sir, I'm also getting the same solution.
Okay, anyone is getting some other solution? Okay, fine. I'll assume that this is straightforward. Okay. Now we did these things, right? Up till this point of we did column in the resulting matrix contains more than 1 0 and all this stuff. Now this, if it may so happen that even after doing up till that point of time, you might not have all the rows and columns which have exactly 1 zeros. What to do then? What does that mean? You possibly cannot means make the penalty 0 for one of the cell elements. In that case, we'll have to go and choose the least penalty wala kind of situation. So what we will do? We draw minimum number of horizontal and vertical lines. How will we draw it? Tick mark the rows in which assignment has not been made. मतलब कोई भी row मतलब none of the cells have marked. So you tick mark that row. Tick mark the column. Tick mark मतलब वो row की just beside the row you just some way you identify that is the row. Again, tick mark the column which has zeros in the marked rows. Means you identify the columns where allocation has been done. Okay, let's see. We will see with an example, otherwise it may confuse you. Draw straight lines through all the unmarked rows and marks. Okay, let's go and see one of those examples. We may not be able to do it this class. We'll see if time permits in the next class. So this is how, once you have done this, you will see after first step all these entities are 0, and then in the step 2 you will have some other zeros. So only the first row has 1 0 and the last row has 1 0. I mean in terms of marking. So when I mark first row, but when I marked first row, the last row wala 0 anyway goes away. Okay, so then I'll start with column. This column has exactly 1 0 and this column has exactly 1 0. So I mark these two. The other rows are anyway bhag gaya. Because I have allocated this, so ye bhag gaya, and this one is left out because I have allocated this. Once I have done that, row 3 and row 5 do not have assignment. Row 3 and row 5 do not have assignments. Now what I do, I mark them. Column 2 have 2 zeros and also marked. So column 2 has additional zeros and then I have a marking here, hence take this column. Okay. So basically row 2 and row 4 and column 2 where it is marked and allocated. Step 5, row 1 has assignments. Baki to this is something. Okay, we will cover it because I'm sure you're getting confused. So what I'm trying to see here is that identifying those rows, those resources where marking has already happened, and those columns where also marking has already happened, means these are kind of allocated. Now I'm kind of running the similar algorithm for the rest of the unallocated cells. Okay, so that I'm ensuring key those are not impacting this current allocation. Okay, so I'm doing exactly same thing here. Smallest element in the matrix which is unmarked means from the remaining of the unmarked entities I am finding out सबसे छोटा कौन सा है, and then I'm proceeding. So I will not confuse you, bore you for more on this. So if we might spend 10-15 minutes on this next class. I'll stop it here. So you can say that, okay, we are done till this point of time. Okay. I'll stop it here for any questions or any other queries related to assignments or anything else. I remembered one question. I'm not sure whether this section or other section raised to, I think, one of the questions of the assignments to understand anecdotally what exactly is happening. That is a little bit time consuming. I do not think that I will have that time in any class. However, feel free to reach to me. I can sit or we can sit together and try to create that understanding. Anyway, thank you. So if
Thank you,
nobody,
sir.
yeah, if no one has any new questions, we may just close it here. Thanks for being late.
Sir, I have a question. In case all the values of a row or column is same, then do we like assign zeros to all the values?
Yes. You assign all the zeros to all the values and follow the same principle, the same logic we have used. Okay. Basically, the last problem was something exactly that same, what we are now saying.
Oops, thank you.
Oh, thank you. So I'll close it because there is another class in 5-10 minutes. Thank you all.
Thank you, sir.